If you're interested in automated testing, you might have seen some contradictory advice. For example, this is a well-known test pyramid suggesting that we should focus mostly on unit tests. And this is another approach called testing trophy, which suggests that we should mostly write integration tests. Some posts argue that unit tests are overrated, and others that they are fine. Which advice should we follow? Let's dive in. Hi, I'm Denis and I'm CTO at Avilum. On this channel, we talk about ways of building better software faster. If you are new to this channel, please subscribe. There will be more videos like this. Today, we are discussing different types of tests and trying to figure out the best testing strategy. Which kinds of tests bring the most value? Let's briefly define terminology. Most commonly, people talk about unit, integration, and end-to-end tests. However, you may also have heard about smoke, functional, system, or contract tests, which all have their place. In this video, we'll focus on the most popular terms: unit, integration, and end-to-end. I'm not saying that it's the best classification, it's just the most common, and it would be enough for us. Okay, so what's the difference? The difference is in the interfaces being tested. Here is a simplified diagram of a typical web application. It includes a front-end app that runs in a browser, a back-end app that runs on the server, a database, and maybe integrations with some external systems. Here we can see different interfaces. First, there is the UI, the user interface through which people can interact with our application. Next, there is an API, application programming interface. There is an API between our app's backend and frontend parts, as well as APIs for integration with external systems. These are network interfaces. Finally, our app has internal interfaces. For example, we most likely use some frameworks or libraries that provide documented interfaces for working with them. Interfaces exist in our code too, from modules to classes to functions. A function call signature is also an interface, which includes parameters accepted by the function and the type of value it may return. Each test interacts with one of these interfaces, and the interface defines the test type. If we test an interface of a small piece of code, such as a single function or a class, we'd call it a unit test. If we test an interface for a larger piece of code, for example an API, we'd call it an integration test. And if we test the UI by emulating user actions right in the user interface, we'd call it an end-to-end test. It would test the application as a whole from the end-user perspective. Let's see how different tests compare to each other. The first obvious difference is speed. Unit tests are the fastest because they test small, isolated pieces of code. Integration tests are a bit slower because they test larger pieces of code. End-to-end tests are the slowest because we have to launch not just our app as a whole, but also another app through which we will emulate user actions. For web applications, it would be a browser managed by a testing framework like Selenium or Playwright. Besides being the slowest, such tests also require more resources like CPU and memory, and their setup process is more complicated. Writing and debugging end-to-end tests could also be more challenging. And this is not only because we'll have to learn another testing framework. The biggest complaint you may hear about end-to-end tests is that they are flaky. You run the test once and it works. You run it once again and it fails. Run it one more time and now it works again. This problem is so widespread that some people resort to retrying failing tests automatically, hoping that they will eventually pass. Why? The answer lies in the principles of how browsers work. They do many things in parallel, sending network requests, handling user input, running JavaScript, and rendering web page content. If some of these operations take slightly longer than usual, it may change the order of events or result in a transit page state when the test expects a final state. Properly written test accounts for all of that, checking the state of intermediate operations and waiting for page elements to appear. Such a test would be perfectly stable and pass 100% of the time. However, it is possible to write a much simpler version of a test that doesn't do all these checks. And it would work most of the time, but sometimes it'll fail for seemingly unclear reasons. This is why end-to-end tests could be flaky. It's just more complex to write them properly, and as a result we often deal with poorly written, unstable tests. You might be looking at this table and wondering why end-to-end tests even exist. They are slow and resource-hungry, and writing them could be more complicated. Well, the thing is, they provide the best confidence. Maybe you've seen memes on the internet like this. If all the low-level tests pass, it does not guarantee that our app works as a whole. End-to-end tests verify the program behavior from the end-user perspective, providing the best confidence that it's actually working. Confidence is the most important reason why we even bother with testing. If we spend time and effort on testing but the confidence level remains low, it doesn't seem like a good investment. Okay, maybe we should focus on end-to-end tests then? Yeah, they are slower and require more effort, but it sounds like a good deal if we get the best confidence in return. End-to-end tests have another benefit. They provide good coverage. If the codebase has no tests yet, we just add a few end-to-end tests and quickly get decent coverage. Well, it's not so simple, and there are reasons why other types of tests exist. First, coverage is a deceptive metric. If we reach 100% of coverage, it doesn't mean that there are no more bugs. This only means that every line of code is now being executed in tests using some combination of input parameters. But the number of all possible combinations of parameters could be huge, more than the number of atoms in the universe. It doesn't seem feasible to test all of them, but testing some could be very beneficial. For example, let's say we have a sign-up form that accepts a user's name, email, and password. It doesn't make sense to try all possible and impossible human names, but trying an empty string, a very long name, names in different languages or special characters makes sense. We may also want to check what happens if an email already exists, or it's not in a valid format, or the password is too short or appears in a leaked password database. To test this form properly, we should run the test not just once, but multiple times, trying different input parameters. Unfortunately, end-to-end tests don't handle this very well due to their slowness. If we want to test 5 different inputs for each field on this form, we'll have to run the test at least 15 times, which will take a while. And this is just one simple form. How long will it take to test the whole application this way? Testing speed matters, so let's see how we can do it more efficiently. Looking inside the app, we'll see that the front end doesn't contain too much logic for this form. It only takes input parameters, passes them to the API, and shows errors returned by the API, or lets users in if they signed up successfully. All validation logic happens on the backend, where we can see separate functions that validate each input parameter. It's probably unnecessary to test all of these chained for each combination. We can write just 2 end-to-end tests for the cases when sign-up succeeds and when it fails. Additionally, we can cover input validation functions with unit tests, which will work much faster and test the required combinations almost instantly. This hybrid approach will work several times faster than pure end-to-end testing, giving us nearly the same confidence. Fast tests give developers quick feedback loop, letting them know when something breaks. Even more, with fast tests, test-driven development becomes possible when the tests are written before the code. I'm not saying that we should always use test-driven development. At the end of the day, it's just a tool. It works great in some cases and not so great in others. However, I would argue that fast tests enable test-driven development. Because if tests are slow, it becomes too painful to run them often, which is needed if we use TDD. The last item in this comparison is refactoring. Remember, in the beginning we discussed that each test interacts with an interface. These interfaces may change over time. New functionality would likely appear in the user interface. Sometimes we may even want to redesign it. It probably won't happen too often because we don't want to frustrate our users, but it may happen. APIs tend to be more stable, especially public APIs. Third-party services or libraries usually care about backward compatibility. They may add new features, but usually don't break things without a reason. As for the internal interfaces, Ideally, we should have the freedom to modify them as we want, if it doesn't break the program for end users. This is where unit tests may become a problem, especially in projects where people meticulously follow the test pyramid. Modifying the code would require changing or rewriting the unit tests as well. And sometimes the effort is so high that developers simply give up. On the other hand, integration tests and end-to-end tests make refactoring easier because these interfaces aren't supposed to change. We just run these tests and quickly verify that the refactored code works. Now, let's answer the question, which test strategy is the best? Should we follow the test pyramid, the testing trophy, or maybe something else? I would argue that none of these, and this is a misleading target. The real values that we should balance are confidence, testing speed, and effort. Confidence is the only reason why we test in the first place. Effort is the price we pay. The less effort we spend, the better. Kent Beck, the author of Test-Driven Development, said, "My philosophy is to test as little as possible to reach a given level of confidence." The third crucial component is speed. A good indicator is how long a test suite runs when we push an update to production. If it only takes a few minutes, excellent. But on some projects it takes many hours, and that's a serious problem. It slows down the development process and represents an elevated risk, because people may skip running all tests for urgent fixes. A common way of improving speed is to run tests in parallel. Enabling a multi-threaded test runner might be enough for a small project. For large projects, it may require a significant investment. For example, Stripe in its annual letter names testing infrastructure as its largest distributed system. The Stripe codebase has 15 million lines of code, and they managed to test changes in it in under 15 minutes, which is impressive. So, what tests should we focus on? I think we should start with high-level tests, integration or end-to-end, because they provide a good level of confidence and make refactoring easy. However, it might be impractical to test all corner cases with these tests due to their slowness. And here, unit tests come to the rescue. Will it result in the testing trophy, test pyramid, or another proportion? I don't know. It depends on the project, and actually it doesn't matter. What matters is that we are happy with the balance of confidence, speed, and effort. We probably can't measure this balance, but I'd like to give you a few ideas of how you can think of it, starting with confidence. Tests are like a bug filter between our codebase and production. If our tests never fail, it means that we never make mistakes, which is unlikely, or the tests are useless. They don't catch anything. By looking at bugs caught by tests and bugs in production, we can get an idea of our confidence level from tests. As for the speed, see how quickly the tests run when we push an update to production. A few minutes is great and many hours is terrible, and there is a grayscale in between. And effort. I think it's important to remember that automated testing should never be the only thing we do to keep our production stable. If we write tests, it's great, but we still need to do manual testing to discover previously unknown bugs. We should also be doing code reviews and have robust production monitoring. All these measures work together and contribute to production stability. By looking at production incidents, we can analyze why they happen and which of these tools might address the issue more efficiently. This would guide our effort. And that's all I have for today. Don't chase those magical tests proportion, it doesn't make sense. Better look at how you could test this particular feature with good confidence, minimal effort, and reasonable speed. And don't hesitate to use whatever kinds of tests if they fit the job. Happy testing!